Hey everyone, welcome back. In today's video, we're gonna burn things with lasers. So I just got this laser engraver from Atomstack. This is their A5 M40 model, which uses a 5-watt laser diode, and that should be plenty of power to do things like engraving wood, as well as precision cutting, which is really what interested me in lasers like this in the first place. The design of these machines is pretty simple, especially if you're familiar with how 3D printers work. It's basically like a 3D printer without the Z-axis. And instead of a filament extruder, it has a laser diode. So this stepper motor over here rotates this rod, which is connected to belts on both sides, and that's what controls the Y-axis motion. Then this stepper motor on top connects to this belt and controls the X-axis motion. This piece is the actual laser unit, and all of those are connected to this controller board in the back. From here, you connect your computer, and that's how you tell it what to print. So yeah, pretty straightforward design. It did require a bit of assembly out of the box, but I'd say it took me maybe 20 minutes to put together, so not bad at all. And they give you everything you need to get started, including some wrenches and everything required to put it together. They also included some sample pieces of wood and acrylic to cut, as well as some safety glasses, which I would highly recommend wearing, not just for when you're trying to escape the matrix, but also if you're interested in protecting your eyes from, lasers. This particular machine is one of the safer ones because the diode is more or less enclosed, and there's even a protective red panel on the front so you can watch the beam safely. But all of this light leak here would be bad to look at directly, and it's going to bounce off of any reflective surfaces, so I would play it safe and wear the glasses anyway. Before we start blasting things with lasers, let's go ahead and take a look at the technical specs. First off, the print area is 410 by 400 millimeters, so whatever you're engraving or cutting has to fit within this space. Although these sides are open, so you could engrave longer items by breaking your image into multiple segments. That way you can slide it through for each one. For my uses though, everything should fit within this workspace. And here they give some examples of the types of materials it can engrave. Things like wood, bamboo, paper, plastic, leather, PCB, oxidized or painted metals. And it's worth mentioning that there really are no diode-based lasers that can directly engrave metal. The wavelength they generate just gets reflected by the metal surface. But you can use the laser to remove a coating from the metal and make images that way. So if you have anodized aluminum, for instance, you can etch an image onto that, just not directly onto bare metal. In terms of what this laser can actually cut through, that would be things like paper, cardboard, fabric, any light wood like plywood or craft wood. It can also cut through things like acrylic or plastic, as long as it's not clear. It'll shine right through clear acrylic without cutting it. But if it's tinted or opaque, you should be fine. The power is listed as 40 watts, but that's not for the laser, that's for the entire machine. They have the laser listed as being 5 to 5.5 watts. The wavelength of the laser is about 445 nanometers. It's fixed focus, and I'll show how that works here in a bit when we start cutting stuff. As far as supported software goes, they recommend Laser Gerbil or Lightburn. I'll be using Laser Gerbil because it's free and open source. But if you want to get into more complicated stuff, you may want to check out Lightburn, which has way more features. So yeah, let's test it out by cutting some cardstock first. Holidays are just around the corner, so I think it would be cool to make some custom greeting cards and gift tags and things like that. And using a machine like this should save a lot of time and allow me to do a lot of detail that would really be a pain to do by hand. They include this metal plate that you can use as a cutting surface, but the laser only goes so far down, so you will need to put something under it to prop it up. I'm just using this chessboard for now. You could probably use a book or something, as long as it's level. Then you need to focus the laser, and that's done by unscrewing this knob on the front, which makes it so you can move the whole laser unit up and down. You want it to be about 2 millimeters away from whatever you're cutting. They include a few of these acrylic pieces that are 2 millimeters thick, So you basically just set the laser on top of that, tighten this knob, and it should be focused. Now if I open up Laser Gerbil, I can connect to the engraver, and at this point, we're pretty much ready to go. Over here, I can move the laser manually. So when I click on these, it'll move the laser around. And with this button, I can set the home point. So this will be the 00 coordinate for my image. Then if I go to Open File, I can pick an image file to burn. I'm going to use an SVG file because it's easier to set your dimensions and to get really precise lines that way. But you can use a typical JPEG or PNG image file as well, especially if you're burning an image instead of cutting lines. Next, you have to set some parameters, and this is where it really just depends on the material you're cutting and what kind of accuracy versus speed trade-off you want. I'm setting mine to 1000 millimeters per minute, and I'm setting the maximum laser intensity to 100%. This will easily cut through cardstock. In fact, it's probably overkill, but this will make sure there's no snags or uncut portions of the line. Once it's imported, you can trace the boundary of the image using this button. And this isn't cutting anything, it's just showing an outline of the image so I can make sure it fits. Now that I have everything lined up, I can hit this button right here and it'll start burning. And that's it. That's how easy this thing is to use. I had never used a laser engraver before getting this machine, and I was still able to put this thing together and start cutting stuff pretty much right out of the box. Beyond cutting things out, it can also be used to engrave images. So if I open up a JPEG image file, I get a bunch of parameters that I can tweak to make the image more engravable. And once that's all sorted out, again I can set the speed and the power and start burning it. And just to show that it can cut through more than cardstock, I decided to crank up the power a bit and cut some Christmas ornaments out of this 1/4 inch basswood. And I mean, these are pretty cool. On the other end of the spectrum, I can also turn the laser down and burn images onto cardstock without even cutting through. That was actually surprising to me. You have a lot of control over the power and speed, so you can fine-tune things to get the effects you want out of different materials. All in all, I'm pretty happy with the performance and versatility of these machines. I don't really have anything to compare it to, but it definitely does what it's advertised as doing, and it does it pretty well. One of the main things I plan to do with this laser is make custom storage containers and project enclosures because it does such precise cuts. But I've already come up with so many project ideas for this thing, like wooden gear mechanisms, board games, greeting cards, Christmas ornaments, all kinds of stuff. And just the ability to engrave images onto things has a lot of gift potential because you can take any anodized aluminum or wooden item and burn a personalized image or message into it. So yeah, that's the Atomstack A5 M40 laser engraver. If any of you are into this kind of thing and you want to see some videos where I actually build stuff with it, like this video or leave a comment below. Because I have several projects planned, but whether or not I record, edit, and upload them really just depends on how much interest there is. So if you are interested, let me know by liking or commenting. But that's it for this video. Thanks for watching everyone, and I will see you next time.